slowly move to the second presentation. It is about adaptive management to coral reef systems in Kenya, addressing land-based pollution problems in marine waters, presented by Cornelius Okello.
Can you hear me? Can you hear me?
Yes, we can hear you.
Let me share my screen then.
Please go ahead.
Sorry, just 1 minute. Share. Can you see the screen?
We can see it.
Perfect.
And we can hear it very well.
Great. So let me begin just briefly introducing myself. My name is Cornelius Okello. I am a lecturer at Machakos University and also an associate at the Institute of Climate Change and Adaptation and ERACOMA. What I'm talking about today is a project that was funded by National Geographic Society that was done a few years ago. We've just finally finished, finally finished analyzing the results and are ready to go to publish it. So it's basically looking at how land-based pollution would impact marine ecosystems, and we took our coral reefs as our indicator species. So quickly, I can just give you some background. I think all of us are aware about the importance of coral reefs and how diverse the ecosystems they are in the universe or on planet, housing about tens of thousands of marine species. So they provide incredible value not only to human beings but also to wildlife in terms of habitats, nurseries, etc. We see that about a third of our marine fish species will live part of their lives in coral reefs. So they now support our fisheries endeavors. They also protect our shorelines from storms and are a billion-dollar industry in terms of food and job creation for people around the world. So what threats are these coral reefs facing? First of all, we have got our big elephant in the room today when we talk about climate change, increase in temperature, increase in greenhouse gases in the atmosphere, which then lead to acidification of the ocean, does pose a threat to corals, specifically because corals are extremely sensitive to temperature and pH. So this can lead to incidences of coral bleaching, where our corals die, leaving behind just the exoskeleton. We also have threats like overfishing. A lot of overfishing activities have been seen to pose a threat to corals in terms of reducing even the coral abundance and not just their population. And finally, we have also the threat of pollution. And pollution here, we're looking at it not in terms of chemicals, but more in terms of nutrient enrichment. And nutrient enrichment will come mostly from land-based sources in form of from raw sewage or from runoff from our agricultural sites. So for the purpose of this study, we really did focus on nutrient enrichment. And this, as we see, can have a myriad of effects on our coastal system. When we have just enough or moderate nutrient, then it becomes beneficial. So because it increases primary production, the polyps, the polyps in the corals, the phytoplankton in the water column need this kind of nutrients. And nutrients here, we're talking about things like nitrates, nitrites, phosphorus, etc. And with this, then you see our fish population will also increase. However, when there's an oversupply of these nutrients, and we expect to have detrimental impacts. So what is considered enough nutrients would range. There's a ratio that has been calculated that was found to be between, when you look at nitrogen phosphorus ratio, would have anything between 4.3 to 1 to 7.2 to 1. So anything beyond this, and if there's ever an imbalance, then we start noticing losses in terms of coral biomass. We start seeing malfunctioning of algae, coral bleaching, or in some instances we get algal blooms, which then choke our coral reefs. Now, we've got a lack of phosphates also causes stress. So what we want to do is have this perfect balance between nitrogen and phosphorus. So not too much or not too little. Now, in areas where there's over-nutrification or too much nutrient enrichment, what we expect to see is, we expect to see increased primary productivity. So phytoplankton biomass will increase. Well, phytoplankton biomass increases, then we expect to see reduction in water clarity and incidences of reduced oxygen. So we start seeing hypoxic or anoxic situations, which then affect coral reefs. When this happens, then we start seeing changes in trophic structures, even trophic interactions, not only between phytoplankton and zooplankton, but also benthic communities, and here we include corals. Also, we expect to see harmful algal blooms when we've got too much nutrients. And there have been incidences where, because of macrophytic vegetation overgrowing due to the excess nutrients, then coral reefs tend to be choked. So this will have an impact also on our fisheries. Now, what we're saying basically in a nutshell is that in a situation where there's too much nutrients or there's over an enrichment of nutrients, then we will see a reduction in biotic diversity in the ecosystem, because very few organisms will be able to survive in these conditions. So with this background, what we set out to do in this study was to understand how nutrient quality and quality would affect marine ecosystems. But that was too broad. So we zeroed in on coral ecosystems specifically as our indicators. And here we're looking at nutrients that are land-based, nutrients coming from the mainland. Our study area was basically the marine protected areas that are found off the coast of Mombasa. Here we have our Marine National Park and our Marine National Reserve. And why it was interesting for us was because, in as much as these areas are protected and human involvement is really minimal, we have a creek, which is the Mtwapa Creek to the north and the Chuda Creek to the south. Now we have got activities that are occurring within these two creeks that are leading to waters being discharged into the marine park, and wanted to see how is this affecting it. Now, because of lack of funding and time, we focused more on the Mtwapa Creek. And why we focus on the Mtwapa Creek is here we have a prison called the Shimolatawa prison that has been found to be releasing raw sewage into the Mtwapa Creek. The reason being that they had a wetland, it's a wetland that was supposed to be cleaning the wastewater that has not been functioning for many years. So we end up having raw sewage. So we were curious, how would this happen? So in this study area, we picked 2 study sites within the creek to understand the quality of water that was getting into the open ocean. And then we picked 2 sites in the marine park and in the marine reserve that were rich with corals. And Kanamai to the north was picked as our control site. And there's a lot of community involvement in this area that conserves the ecosystems there. So what we basically did was we collected water samples where we measured your basic parameters: water, dissolved oxygen, suspended solids, pH, temperature, etc. And we also wanted to look at the primary productivity. So we looked at chlorophyll A, how much chlorophyll A was in the water samples. We also looked at the amount of nitrates, nitrites, and phosphorus. So we wanted to understand the water quality that was in the creek as well as the protected areas. The other thing we did was we also looked at the coral health. Now this was being done. This was part of a monitoring program that has been ongoing, that is being led by KWS, where every month they use the quadratic methodology, where they count the number of healthy corals in a given space. So what we were looking at specifically was looking at the health in terms of density, color, biodiversity, and presence of also fleshy algae. Now, so far, our results were quite interesting. where we noticed, first of all, that the temperature was higher towards the creek, and the temperature reduced as we went into the open ocean. However, the temperatures that we found were not enough to have an influence on the coral health, because that temperature is what you'd expect corals to thrive. The same was also found for pH and salinity. However, we found that the amount of total suspended solids, chlorophyll A, phosphorus, and nitrogen, and nitrates and nitrogen tended to be higher than what we'd expect. So we figured that the availability of these nutrients, chlorophyll A was telling us that the primary productivity in this water tended to be higher than what would be expected in other waters, meaning that the nitrogen, the nitrates and nitrites, and the phosphorus that was in the water was causing a lot of productivity, which we have, as we've seen in the background information, does have an effect on the benthic communities. So the total suspended solids across the oil stations were higher than recommended standards, suggesting that this would be a contributing factor in the deterioration of coral health. We also saw that the nitrogen, the nutrient load in the water was greater than the amount needed to maintain 50% of coral reef coverage, meaning that the excess nutrients that were coming in from the creek would be a major contributing factor to the coral health, of the communities in this particular area. Then, when we analyzed the data on the coral health, we used a methodology that was developed by Kawaka et al., who work for Kodio, where they classified corals into three groups: unhealthy, fair, and healthy, where unhealthy corals would cover 15% of the total area would be live corals, and more than 21% would be algal cover. For fair, it would be between 50 and 30% live coral cover, and between 6 and 20% algal cover. And then healthy corals would have more than 30% of live corals and 0 to 5% algal cover. So in our results, we found that majority of our corals were either fair, where we found some areas that got 17% live or hard corals, while the soft corals were less than 2%, and the macroalgae were more than 22%. So this told us that our coral reefs were either fairly healthy or unhealthy. So from this, we find that based on our results, nutrient quality and quality were found to be higher than recommended standards by international communities, meaning that they're a limiting factor to coral health, telling us that from the results, we saw that the nutrients were highest in the creek, and as we went deeper into the marine reserve and the marine park, they tended to be lower because of more mixing from ocean water, but still the nutrients within the marine protected areas was higher than what was recommended. And this meant that the coral health was being impacted, meaning it was fair and healthy. We also observed that based on our observations and anecdotal evidence, that it would be misleading to say that the point of pollution was specifically from the creek. It has been observed and also corroborated by people around the area that all the developments along the coast, despite there being a ban, despite there being a restriction of disposing sewage or wastewater into the ocean, some of the hotels, some of the residential areas were still doing that in the cover of night. So this means that we need to go back in there and really assess and find exactly where the source is, right? And the second thing is that we also did not look at Tudor Creek, which could have been seen to be a major contributor to this, because we have the general hospital there that is also releasing that is also releasing waste into the creek. So our conclusion is that if we are to engage in any serious conservation efforts within the marine park and the marine reserve, we need to consider land-based pollution as part of a holistic and integrated coastal zone management approach. Instead of just concentrating on only what is happening in the marine space, we also need to consider what's happening in the landward side, and make it part of our conservation efforts, so that we can be able to curtail or reduce the amount of nutrients that are being discharged into the marine environment. So unfortunately, my co-authors couldn't join us today, but I'd just like to mention them. We had got Dr. Margaret Awor, Dr. Arthur Chuda, Nancy Kodwor, Josephine and Gilbert, both from Kemfrey. Also, would like to give a special thanks to Kemfrey, who helped us with our data analysis, especially for the water quality. The Kenya Wildlife Service, who basically helped us a lot with the data collection and give us access to the marine park, and National Geographic for basically providing funding for this project. Thank you very much.
Thank you very much, Cornelius, for this brilliant presentation. Any question? I see Hoke is raising hand.
Oh, sorry. Margaret has told me she's here. I said she's not here, but she's around.
Yes. Yes. Okay, go ahead with your question.
There was a clapping hand.
Okay.
I was applauding. But,
sorry.
But no, we're excellent talk. I really enjoyed not only the content but also the style. It's really nice listening to your talk. Yeah, is there any way in terms of mitigation or implementation of measures that you could see of addressing this issue? Because I mean, it's like a worldwide issue. It's not only in Kenya. We have the same problem in Germany as well. In the Baltic Sea is polluted so badly, but I think there's very little being done about it. So you think it's more easy to address it on a local level? So contact the prison, try to find mitigation measures, or does it need to be like a national or regional initiative?
In my thinking, I think it's both. It has to be a local issue and has to be addressed from the national level. From the national level, we have policies that do govern wastewater management, but there seems to be a gap in the implementation of these policies. So we need to be more careful with the implementation of it. But ultimately, I still do believe that the answer to it would basically be integrating, not having this silo kind of approach where we are managing our marine ecosystems in one side, and then we've got an entirely different organization managing our land-based activities, especially since they are being linked. And if you're looking at water, this is just looking at the marine ecosystem and what is at the coast. When you're looking at some of these rivers like the Tana River and the Athi River that come all the way from the inland, the activities happening up there will have an impact on the ocean. So we still do need to have this, we know we need to talk to each other and not just work in our silos. I think that for me would be a more worthwhile endeavor.
Yeah, thanks for sharing. I think you're a point on that we need to have the whole picture in mind when trying to make changes. Thanks a lot.
Thank you.
I see Juliet raising hand.
Yes, thank you so much, Okello. It was a very interesting talk, and I have a question. Did you check on the current dynamics, or the water flow from the creek? How does it go? Does it go southwards or northwards? And does that affect the transport of the nutrients further to Nyali? And if you say that it's urban, so there could be other sources of pollution from sewage disposal, and do you know like the points where that the source could be coming from, in between or also through the creek?
Thank you. That's actually a very good question. When we started the project, we actually had a partner on board who was going to do some sort of mapping using heat and seeing how the currents move and where they distribute etc. Unfortunately, as the project progressed, she was not able to continue, so she dropped off. Now, we used Kanamai as our control site, so to see that now that became our way of looking at the flow of water to see what the concentration looks like in Kanamai. And from our results, we saw that Kanamai was not that much, didn't have that much concentration as opposed to Nyali. Now, this might be because Kanamai is a bit farther away, but we know we may not really get there without further investigation. In terms of sources of pollution, when we went in there, we were very focused on Shimolatawa prison being a point source, because even if you look at the issues, it could not only be Shimolatawa, there could be diffuse sources from upstream, because you've got farmlands upstream that probably there's erosion happening there from farmlands where nutrients from fertilizers are getting into the water. So it became, based on the scope of our study and the time limitations, we had to really narrow and focus. And that's why, as we concluded, we put in this disclaimer that we focused on this one thing, but it's not the only thing. We understand that there are many dynamics there. In fact, some people we talked to on the ground argued that in as much as we look at Shimolatawa as a point source, and I even have videos, I should have shared them, videos of the water coming from the prison into the creek. But we have hotels, again, this is anecdotal, so we have no way of corroborating it, of people who said that they have seen hotels right next to, that are just adjacent to the Marine National Park, actually releasing raw sewage in the dead of the night, right? So you see, now that it becomes tricky, because it becomes also a political situation where if you go in there, you don't know whose toes you're stepping on, and you might end up, as the mafia says, sleeping with the fishes. So we focused on something, but again, there is still space for this study to be expanded. There is still there are still a lot of unknowns. What we know for sure is that nutrients are coming from the landward side. The nutrients are a limiting factor to coral health. We've made this connection. So now we need to go further and find out what is the source, where are they coming from specifically.
Thank you very much, Cornelius, for this very brilliant presentation. And I think, as Hauke said, it is a global problem in each country, in each cities. This issue is also present. So we can continue this discussion during the next session, or separately, remotely, of course. Yes. But I think we have arrived to the end of this session, and this is now the time of the tea break. So thank for the presenters, and thank you also for to the audience for this session. And we'll catch up at 1 p.m. for the next session. Thank you very much, everyone.